So before moving on, let me demonstrate to you how the finished product actually works. So in here we have a PgAdmin which is connected to our database. You can see there's 4 entries right now. Let me just, yeah, there's 4 entries right here. So now if I go back here and click on this image, the front end should take 3 different images of the user and save it in the database, right? So I'll click this eye icon. As you can see, it's the webcam is on and we should see a post request right here. Yep. Yeah, so we've been redirected to the dashboard because the response was successful. As for the payload, we have 3 different files. Response, it's generated 3 unique IDs of the user. So now if I go back to PgAdmin right here and run the SQL command, you can see this 5 entries. I wanted to do something different this time. So generally when I post a video on YouTube, it's only the successful ones that make it over there. But I kind of got fed up of that, and I have, generally, if you see my Notion document, I have a bunch of different ideas, and I also wanted to start documenting all the failures which I've had along the way. So, so one of those projects which I wanted to build was this face detection login system, where we have 3 different environments. So the backend is in Go or probably Express. I'm not too sure at the moment. We'll have a database that will capture the data of the user. We'll have a face detection algorithm in Python, and we'll have a front end in Next.js, which uses some kind of animation. I've actually seen a library called Rive, which has these cool little animations which you can play around with. So we'll have that animation that will be able to capture the, which will generally be an animation while the system is capturing the image of the user, right? So this is what I plan to build, and actually I've also have the rough outline of how the skeleton of the project looks. So I have 3 different environments again: the Flask server, front end, and Go backend. So front end is again hosted here. If I go here, it's, I think, the latest version of Next.js, which is 14. And we're so if I go here and if I go to app.js, which is should be right here, and in here I have my webcam, and the webcam, I've installed a package called React Webcam that allows us to access the PC's image. And yeah, this is just simple stuff. I just copied from the documentation. So if I go to the browser in here and turn on the webcam, yeah, you can probably see me. Hello. I actually just noticed the closet's open for some reason, probably while setting this up. Anyway, so this is the front end which has the image, which will capture the image. I'm not too sure how it will look at the moment, but we'll obviously iterate over this. So this is the image. We can just capture the image. We can turn the camera on as well. So I'll just turn it off for now, and I'll show you the backend as well. So again, if I go back here, I have a Go backend, main.go. Again, this is all just Golang. It doesn't have, I've not installed any libraries, Gin or Golang or anything. So yeah, I've started a server in 8080, port 8080 right here. And we hit this endpoint login. So if I go to this function right here, handle login, these are all the boilerplates that's required for sending a file. So in here, I think this is where the magic happens. So we hit an endpoint to a Flask server, which is running on port 5000. Is it mentioned here? Where does it mention? Anyway, this is a port 5000, believe me. So in port 5000, we hit this endpoint called face recognition, which is a Flask server, which I'll show you in a moment. We hit it, Python does its magic, and it gives us some ID, and then we display that ID. We send it back as a JSON response. So now if I'll be showing all of this to you. I'll demonstrate this in just a moment. I can see. So this is our Flask server. So in here we just have one method, post method. This is the important package. Again, I probably use OpenCV maybe, but this was just to get the flow of the application right. So yeah, so we get the file from here, and then this is again the main function, which we give it our image in here, and once this fires, it gives us a unique location of that face location. So this is not secure at the moment. It just gives you the top right, bottom left position of your face. Then I append a string here, so you can see, and then I return the unique ID. We return it, JSONify it, send it back to the server, and voila, we get it. So yeah, enough of me talking, and I'll go to Postman right here. I have a endpoint right here, localhost 8080 login. So this is the endpoint. So in here, what I can do is I can just append a file. So let's say mail face. I already have a face right here. I send it the face, and I get a unique ID right here. You can see right here T98 and so on. So if I give it a lady face now, go here and lady, and if I give it this face, I get T1196. So just to make sure that I'm not bullshitting, I'll just go again mail face. I hit mail face and hit this endpoint T98 again, the same unique ID. So this is what I'm going by at the moment. If you have any recommendation on the packages that I should be installing, specific packages for specific use cases, let me know in the comment section. Feel free to criticize it as well. That'll be fun reading. And yeah, so I'll also have to put in Docker for orchestrating everything, how all these environments work together. But this is the rough outline of what I have created so far, and let's see, either this will be successful or we'll burn it to the ground. Either way, it will be fun. This will be the front end portion of the facial recognition system. So instead of having that standard webcam which you saw in the first video which I posted, where we actually show the user the his face and then it recognizes it, so I wanted to make it a bit more interesting. So I have this cool little animation, this eye like animation, and if I open my dev tools right here, you can see that behind the scenes it's actually taking the images. So if I copy one of those images and go in here, paste it right here, you should see my you should see my picture while I was talking. So it's kind of weird. So this was one of the pictures it took. So if I show you how it looks when the user first enters this page, so it looks kind of like this, and when I click this little eye icon here, you can see that it starts playing and now it starts taking images. So it should take 5 images and then stop. So the idea was to take 5 different images of the user and send it to the backend, and the Python model would extract the best features among the 5 images and recognize the user. Again, it just takes 5 and it stops. And if I copy one of those messages that I console logged earlier, you can see yeah, my it's taken my image right here. So I'll show you how we'll go over the code on how I did this, and yeah, let us just continue to the code. So this is the code right here. So this is the mono repo. You can see we have the backend, frontend, and the Flask server. So let us just go over the front end because that is the main aspect of this video. So you can see this is the main page.tsx. I have a face login component which consists of 2 other components called the my webcam and Rive canvas, right? So my webcam is similar to how it was in the first video. So this just defines a webcam from React webcam package, and we just turn it on in here. That's it. So you can see here we pass in the props to turn it on. It doesn't do much. It's not very interesting, and probably the main thing over here is this right here. So opacity 0. So what we're doing in this right here is behind this, it's actually 2 components. So behind this is my webcam, and I've turned the opacity to 0 so that we don't need to show the user his image. So that's probably it, opacity 0. And what we do is we basically overlay the Rive canvas on top of the my webcam. So yeah, so in here we have the capture function. So what this basically does is it takes the image of the user and console logs it out for now. Later on, we'll probably write the logic for storing the 5 images and sending to the backend. But this is just for the demonstration purposes to show you what the image looks like. So let us go to the more interesting part, which is this component right here, which is called Rive canvas. So again, this is installed from this package right here, which is called @rive app react canvas. So this is the component, how it looks like. But let me talk a little bit on what this Rive is actually about. So Rive is a tool that allows us to create all these cool kind of animation in our web app, and I believe it's relatively easier than most animation softwares. It's yeah, you can see all these different demos in here. Yeah, so yeah, you can see it's, you can build all sorts of things with this. But let's just show you how it works. So let me go to get started in here, let it load, and yeah. So yeah, so this is how it should look like, the dashboard. So what I did was I basically created I pressed plus, and we have this 5 different starter templates which we can use and build upon it. So luckily I found this one which is called cursor tracking, which is already pre-built for us. So if I open this right here and I click create, it should create one. Let me just wait for some time. Okay, for some reason it's not creating, but for y'all I maxed out my limits on the free trial. Okay, so you just press create and it should create the template for you. So if I click here, see, so this is one of, I was playing around it with it, so I have 2 of the same kind. This is how it should look when you first enter this page. So you can see this eye icon with this artboard right here, and if I click on this animate tab here, it should pop up a new tab below our window. And if I click on state machines and if I click on play, you can see all these different inputs. So if I click one of those, so let me go to preview. So preview should already be built for you. So what I did was I just double click this and click duplicate, and I was just playing around on how it should look like. So if I go to one of those, so and play, you can see this plays right here. So what I did was I just played around with the keyframes for the movement of the eye. So what I did was in this move, the starting, I just changed the location, like the position, sorry, and I played, I stopped again, and in this time, which is 1 second, I moved it right here. So now if I go back here, it should move the position of the eye. So again, in this, if in the 2 second time frame, I move the eye and go back right here, you can see it starts moving. Yeah, so that's what I basically did. I didn't go for creating even more complex animations because frankly speaking it would take too much time, and I was, yeah, just to do just to do this positioning of the eye took me probably an hour. I was just figuring how things work. But a YouTuber called Developed by Ed has a very good video on this. He goes over the basics of how this you can create all this animation. I'll just leave a link for his video down below. So that's basically it. And after creating a duplicate of the preview, and this was, I think, how it looked finally. So if I go back here, yeah, so this was how it looked towards the end. You can see here I created all these different animation. It's probably preview 3 which I ended up using. Yeah, so what I did was after creating the one which I was satisfied with, I went to state machines right here, and you can see this is how we can link all these different animations together. So we have icon pressed on off. You should have the same thing. So in the blink tab, what I did was you should have this blink button kind of thing right here. So what I did was I just dragged my preview right here, and I linked it up, linked the blink with preview 3. That's all I did, and everything just seemed to work. So if I click again play right here, if I click on the icon, you can see it, this canvas right here moves. So that's what I did. And the other change which I made was in this new artboard, what I did was I changed the aspect ratio to the width 1920 and height 1080. You can also change the background color if you want, so you can make it red, or you could make it transparent. It's all up to your creativity, but I left it at white. So that's what I did, and I just downloaded this. So the way you download it is just press this icon right here, press download, and for runtime Rive, right? So it should download a file for you called cursor tracking, and just rename this to whatever you feel is appropriate. So yeah, so that's basically it for this part. So let me go back over to the code. So yeah, so in here we use the use Rive hook, and extract the, and just put in the Rive component, and you put in all the configuration. So the source, so the file which you downloaded, you put it into the public folder, and I renamed it to i.riv. Never mind this, I'll probably delete this. I was checking out all the other templates as well, so this is one among them. So yeah, so i.riv, just put in your public folder and mention the path to it. And this is also quite important. I've got an error because I was putting in the wrong state machine and the artboard. So if I go back to my Google Chrome, so you should put in the name of this artboard over there, new artboard, and also the state machine. So mine is just called state machine 1. So I think this is by default, and it's also by default. So you just mention that over here, and yeah, so that's probably it for the use Rive hook. And yeah, so in the Rive component right here, if you just put this Rive component, you should see that the eye icon, and if you click it, it should start animating it. So what I did was I put in an on click listener on this Rive component and defined a function called handle capture photo. So inside this function, what we do is we see if is webcam on, which basically sees whether the webcam is on or not, and if it's on, we just exit out of this function. So this is just a check, and we, if it is not on, we set the webcam to on, true. And again, this is where we take multiple photos of the user. So I use the set interval web API. We trigger the capture function, and this capture count is a variable that tracks how many times this capture function should trigger. So in our case, every time this function triggers, I increment the capture count, and once it hits 5, we turn the webcam off. We clear the interval, because whenever you're subscribing to a web API, it is always a good idea to clear the interval, because then it would just create memory leaks. So just clear, just unsubscribe to the events which you've subscribed to the web APIs. And yeah, so we define the time, so every 2 seconds keep triggering the interval, and run this capture function. And yeah, so and we use the use effect to basically clean out our interval. Yeah, so we clean, we unsubscribe to it, and we clear the interval. So yeah, so that's basically it for this video. These are all the important things, I believe. And if you have any doubts, let me know in the comment section below. So yeah, so this is it for the front end, and I'll see you all in the next video. Thanks for watching. A quick update: all the code which was shown earlier can be found in this repository called face detection system, and it's under this branch called F animation. So if you want all the changes which were shown in this video, just check out to this branch F animations, and you'll find it all there. All right, thanks. Migrated the backend for our face detection system from Golang to Express, just because I realized that I was using Golang for the sake of using it, and the techniques that differentiates Golang from Express, which is its concurrency techniques. One of my primary motivators of using it was not actually being utilized for this project, so I didn't really see the need of using Golang. The second reason being that my competency level in Golang is not in par of what I want it to be. So those two being the reason I migrated the backend from Golang to Express. Perhaps this might be a mistake that I'll realize moving forward, but for the time being, Express meets all the requirements that is laid down by this project. So let me just go over what we've done so far. For those of y'all who aren't well versed with Git, let me show you how to get the latest changes from our repo if you watched the last video. And for those of you all who already know how to use it, you can just skip this section. I'll provide a timestamp below. So as you can see here, we are in our VS Code right here, our code base. This is our face detection system. And if you're using ZSH or MyZesh, you will have this color scheme as well. So if you don't, you can just install it. It's quite straightforward. So this right here is our branch. So we are in our main branch right here. And what you have to do is you have to get the latest changes from our GitHub. So what you'll have to type in is git pull. This will get all the latest changes from our GitHub, and as you can see, mine is already up to date with all the latest changes, but in your case you'll probably have new branches here, which is called F3 backend. So once that is done, what you have to do is you have to check out to that branch. So if you go to GitHub right here, you can see there are 3 branches. We have to go to our F3 backend, which is for this video. So let's go back here and say F3 backend. So you can see we have F3 backend right here, and that Golang was deleted and all the latest changes have come here. So once that's done, step in clear. I'll clear everything out. So the first instance of ZSH will have will cd to backend. So backend, we are in our backend. We can run our server, and okay, so we you probably get this error because you'll have to install the latest changes from the package.json as well. So yeah, so with this now you can run the server. All right, listening on port undefined. Okay, so this is because if you go to our source index.ts, we're using port from this constants folder, which is taking in from an env file which we don't have. So what we can do is I'll also change this. If this is not there, we can use port 8080, but since we are using it, I'll create a .env file here, and you can see I've provided the env sample. So in this we have env samples are meant to see what are there in env, so we can just give it paste the same thing here, port 8080. We'll save that, and now you can see listening on port 8080. I'll just restart the server, so you can see, yeah, so we have our we are listening to our port 8080. So the next step is to fire up a Flask server. So we have a virtual environment in here. So in order to start that, what you have to do is press in source env bin activate. So this will start the virtual environment for us. So as you can see, it's env here. That means we have started our virtual environment. Now to start the Flask server, you can type in Python 3 Flask server. So this should be small letter. So if you can see a Flask server, and under this Flask server we have to go to flask server.py. So you can just type in flask server.py and hit enter. So this would start our Flask server. Yeah, so we've started our Flask server as well. So let me show you what changes I've made. Let me go to the code base, and setting up this backend Express took some time. Just let me know in the comment section below whether there's any tools for setting it up. but for in our case I've manually installed each and every package, the .env, node-mon, the tsconfig, all that. If you want to know how to do that, let me know. I'll probably record a video for that as well. Okay, anyway, let's go to the main bread and butter of our project for this video anyway. So in here we have plain express code, and we have this login route in which we have a login controller. But before that, there's something else in here which is called Mutler. So Mutler is something that allows Express to use form data. So Express doesn't come out of the box to accept forms. So we use Mutler to enable Express to use basically form data. So the idea was to get the file data, which was the image of the user, to the backend, and the backend would save it somewhere. So in our case, it saves us in this folder called uploads, but I'm getting too ahead of myself, so let me go to this controller which actually shows everything. So we have this Mutler middleware. I've abstracted it. So if you go here, this just sets up everything. So when you're using Mutler, you need some configurations, which is this, and then you mention the storage. So in our case, we want to store this somewhere, so we store it in a uploads folder in our root directory. So this right here, uploads, and we give the file name with whatever the file is being uploaded. So this just saves it. And if I go back here, we use that MATLAB middleware. So instead of having all this boilerplate in our main index.ts file, we just abstract it out with the middleware right here. We have this upload constant, and this just whenever you're uploading a form type, this is how you do it in Express, upload.single. So as we are just sending a single file at the moment, it's single dot file, and this file is basically the key. So if I go to Postman right here, key this file, if it was named something else, you would name it something else in here. So if it was like user, it would be user, and the key would also be user, but in our case it's file. So then we have the controller right here. So again, we're sticking to best practices, so I've abstracted that out as well. So the login controller is again pretty simple. We get the file from the request, we check whether the file exists. If not, we say no file found, and we hit a response post request to the Flask endpoint. Again, all these constants have been stored in a constants file. So let me go back here, and for the data we just send in the file name. So what is happening here is, before what was happening is, if I go back to Mozilla, to our main, if I go to the Flask server, what was happening is we were sending the form data from Frontend. No, I haven't actually done that. We were sending from Golang to Flask server the file form data type. The Flask server used to save it in a upload folder and used to again delete it as well. So let me just wait for this, open. Yeah, so in here you can see we received the file type from our Golang backend. We used to create a upload folder, we used to save it, we used to access the file path, and we used to also delete that file path. So that was what we were doing before, but now in the latest code, what we are doing is using Mutler, we save it in our uploads folder. And if I go to our Flask server, flaskserver.py right here, okay, let me just show you that as well. So for the payload, I send in the file name, and we receive that file name in here. So right here as data parameter, user picture name, and image path, we access the uploads folder, we give in the user picture name. So Flask takes in whatever the image was saved. I'll show you again with Postman how this works, and we generate a unique ID, we JSONify it, we send it back to the backend right here. So right here, whatever the status is, the unique ID which we get, we send it as a response. So let me show this in Postman how it works. So let me go back to the code. You can see we have phase 1, phase 2, But okay, let me just delete one. Fine, let me go back to Postman, and in Postman you can see I'm hitting this endpoint localhost 8080 login and the keys file. Let me select a file. We'll say man face. Do I have it? I have to find it. Okay, let me just face lady. We have face man. Okay, let's just use face lady. So we have face lady open. So face lady.jpg, we send it and we get an access error. Let me go back here. You can see we've uploaded a face lady.jpg and probably Python cannot identify image file jpg. Okay, so I believe the problem is because this model cannot identify this face lady.jpg. So let's do another thing. Let me go back to Postman. Instead of face lady, let's try with male face. Okay, open, and let me send another request here. Okay, cool. So we're getting T98R356. The problem is with an image. We probably will have to change the model which we're using here. OpenCV comes to my mind. Let me know whether there are any other ones. Yeah, so anyway, so you can see here we have uploaded male face. Our Mutler has uploaded the face over here, and Flask server just accesses the path to that image and we get the unique ID. So that's how the flow is currently for this project. So moving forward, we'll probably Dockerize the application instead of like writing starting up the server individual. Probably Dockerize it. We'll also incorporate the database, so when instead of saving it in this uploads folder, we'll probably save the unique ID and the I think we'll also save the file image as well. We'll see. We'll moving on, you'll come to anyway. For me, I'll have to figure that out. So that's as far as I've worked up until this point. If you have any suggestions, let me know down in the comment section. Yeah, if you want to criticize it, go for it. I would love to hear your criticism. Make sure it's constructive, of course. Yeah, so thanks for watching. See you all in the next video. We have finally made the connection between the front-end, back-end and the AI model for our face detection system. So let me begin by quickly showing you how all of this works. So if I open my DevTools right here and if I click, you can see here a red icon appears in Chrome, which means the camera is activated, and within 5 seconds an API call should be made. And 5 seconds because we are taking 5 different images of the user every 1 second. So yeah, we've made a call here, and as for the payload, we are sending 5 different files of the user, which is captured through the webcam. And as for the response, you can see here we have 5 different objects: the file name, user image, and the face ID for that image which we have provided to the backend. So this is what we've done so far. Let me quickly go over the changes which has been made from the last video. So let's go over to VS Code. So in my VS Code here, I have 3 instances of my terminal here: the front end, back end, and FastApi. In the last video, I showed you how to take a pull request and how to set this all up. So the only difference is probably the FastApi. So the biggest change in this video from the previous one is me changing from Flask to FastApi. So we'll go over that shortly. Let me just show you how we start our FastApi. So this is the command Python 3, the mflag uvcon main :app -- reload. So if you hit enter, this starts the FastApi server, which I'll go over shortly. So let me start from the front end. So in the front end, we have this main file here called page.tsx. Again, everything is same from the first video. Face login, we have 2 components. All of this I go over in detail in the first video, part 1. So in the Rive canvas, the only different change which has been made is we have a state now called image files, and this image file stores all the images that have been captured by the webcam. So right here, again, I've gone over this, so I don't want to waste your time. So if there is a file, we just push it into the state, and this is a file type. Yeah, so in the use, there's a use effect now. So this is the new thing which was added. So in here what we do is we check whether the image files dot length is equal to 5. So that means there is 5 different files in that image file state, which means we've captured the images that is being needed by the backend. And here this is an API call. So API request. So if it's in the utils /api.ts file. So in here we put all our APIs right here. So in here what we are doing is we are creating a custom access which is called FDS access. I just named it that way, and we give it the base URL, which is, if there is one in the env file, we use that, or else we use the one which we provide right here. So this is because we don't want to reiterate the same thing over and over again. So instead we just define a base URL over here once, and then we can just put in the endpoint which we want to hit. So we have a post request called login with face ID, which is the Express API endpoint. We are just console logging the data out for now. So in the upcoming videos we probably will redirect the user somewhere else, but for now this is what is happening in the front end. And I believe the other change which has been made is this. I can't recall whether I've explained this. So what's happening here is the image which is being collected by the webcam is of a URL type. So we just convert it into a file type and we send it to the backend. So here this is the function which transforms that image source into a file type, and in the Rive canvas we just push that file in here. So that's what's happening in the front end, and that's it for the front end. Let's go to the backend. So the backend also, I haven't made much changes here. So the main changes, rather than having the API routes here, we define one route which will contain the logic. So you could name this whatever you want. I chose to name it router for now. So here we define the prefix, which is API v1 versioning of our API, and then we have all our routes in this router folder right here. So router index.js. So if I go in here, this will contain all our routes. So say if this was a authentication router, we would define an auth route and have all the routes for authentication in one place, which gives us a better structure for our code. So we have just one endpoint, which is login with face ID, and again I've gone over this in the previous video, part 2 I believe. And we have a login controller. So this contains all the logic, the bread and butter of our route. So in here what is happening is, again we check if there is files coming in. If it's not there, we just say no files uploaded, error handling here. And probably this here what is happening is we call in the fast API endpoint, and all of these constants are in this constants folder right here. Yeah, so in here again, for now what we are doing is we are just collecting the data and sending it back to the front end. So in here in the upcoming videos we'll probably have the logic for storing that in a database. So again, this is new compared to the last video, which is whenever there is a file being uploaded, the Express puts it in this folder called uploads, and this logic right here, these line of code is the code that tells it, once there is a response from fast API, remove that from this folder, so that we just to save space, if you wanted to collect the images, or you wanted to put it in some kind of cloud storage like S3 bucket, you probably would do this a little bit different. You wouldn't want to remove it, but for now what we are doing is once this endpoint is hit, the images are stored here for a short duration of time. We make a call to the fast API once we receive the data, we clear those images from this uploads folder. So then, okay, so that's it for the backend as well. I've not made much changes. So this folder is probably something very new compared to the last one, because last time we were using Flask and now I decided to change it to FastApi because one of the subscribers recommended me to do so, and after reading up on it, I believe it's much more faster than Flask, and it doesn't have a very large learning curve as well. So it made sense for me to use FastApi, and it was fun because it was something new. I've never really tried FastApi, and I kind of liked it as well. So in here, what is happening is, so once we hit that express endpoint, if you remember, the login.ts right here, if once we hit this endpoint, for a short duration of time, that images is being stored in this uploads folder, right? So what happens here is Python refers to that uploads folder. So the logic is right here. It looks at this uploads folder, picks up the images and processes the images to get the face ID. So this is all the logic right here. So get image ID, and we get the image. We generate the unique face ID and we put it into an image list right here. So that's basically it. And if we don't have a face ID, we just give a message saying no face found in any images, and if there is, we just send it to the back to Express, and Express sends it to the front end. So that's all I've done so far. And the reason this video is just the connection between the three different environments is because I was actually planning to put the logic for the database as well, but then the video would be a bit too long as I've already changed from Flask to FastApi, and I'm trying to make the videos a lot more shorter so that it's bite-sized information which can be easily processed and I don't end up wasting your valuable time. So that's the reason why I chose to do this. And even if you're not genuinely curious about the project itself, like the face detection system, I know it's a bit generic, but I believe there is some value in going over how environments work and how you structure a mono repo, and I've tried to the best of my abilities to structure it like that, like how you would see in a production grade environment and how we use it professionally. So that's the main intention for recording these videos, because when I was first starting, I had no idea. For me, Next.js was it, like it was a full stack application, so that's it. But generally speaking, it doesn't go that way. In a professional context, you would generally have a lot more environments than just one Next.js. So if you're a front-end developer, back-end developer, it makes sense for you to know how different things work. So that's the main intention of recording these videos, and hopefully you derive some value from it. I'll see you all in the next video. This video will be finally connecting all the missing links which was there previously. So we have a database to store the user's face ID, and we will also dockerize this entire application so that it is packaged in a way that is easily deployable. So before moving on, let me demonstrate to you how the finished product actually works. So in here we have a PgAdmin which is connected to our database. You can see there's 4 entries right now. There's 4 entries right here. So now if I go back here and click on this image, the front end should take 3 different images of the user and save it in the database, right? So I'll click this eye icon. As you can see, it's the webcam is on, and we should see a post request right here. So we've been redirected to the dashboard because the response was successful. As for the payload, we have 3 different files. Response, it's generated 3 unique IDs of the user. So now if I go back to PgAdmin right here and run the SQL command, you can see there's 5 entries. So let me go over the code and how it has changed from the previous video. In our VS Code right here, you can see our Docker container is up and running here. And if I go to the Docker desktop, which is a very useful tool, in our containers right here, you can see our multi-container is running, and inside that we have 4 different smaller containers, which is the Postgres face, the front-end, backend, and the FastApi, right? So some of the useful tools which you can use, especially when you're using something like Docker and the database and all, is Docker Desktop. It makes your life much more easier if you have this installed. You can just interact with your containers much more efficiently here. And the other one is this PgAdmin right here. So when you have database, you can run SQL queries and see the data that is being stored. So these are some useful tools which you may or may not like, but I generally use them. Just give it a go and let me know how you all like it. So as for the code, if you go to let's start with the front end, and I'll show you how to run this Docker compose and all. But let's just start off with the changes which was made from the previous video. So let us go under app. We'll go to page.tsx, and in here we have a face login. Nothing changed here, and in here also nothing has changed. So let me go to Rive canvas. The only change which was made was, before we were capturing 5 images and now we are just capturing 3, just because it was taking a lot more time. 2 seconds for every image was way too much, and I wanted to shorten that duration. So we are capturing just 3 images, which takes about 6 seconds, right? And now if we go to our APIs folder, which is in our front end, so right here what we are doing is, once we have a response or status of 200, we just reroute the user to this dashboard page which was created, which is nothing but which just says welcome to the dashboard. Nothing much has changed in front end, just a few tweaks, that's it. So I'll close the front end part. So that was the only changes which was made in the front end. Now let us go to our backend. So the backend, I believe we've made a little more changes. So we've just added a few more lines of code which gracefully shuts down and disconnects the DB. But the main change which was made is probably this DB connection. So I've installed Sequelize, which is the ORM which I chose to make queries to our database. Again, all of this you can find in their documentation. It's pretty straightforward. The only thing is probably this thing, Postgres DB. So what is which is taken from a constants file. So if I go here, okay. So here what we are doing is we are picking environment variables from our env file and inserting it to our to initiate our Sequelize. And if it's not there, we just use the localhost 5432, the default values, right? And these environment variables are actually coming from our Docker compose file right here. I'll go over this in a moment. Let's go to Express for now, and that's about it for this file. We just initialize the Sequelize, and we just said we have a function for the establishing a connection with the database and disconnecting the connection with our database. That's it for this file. And the other important change which I made was probably this one, Multer. And I've realized that I was calling this Muttler throughout these videos, and it's actually Multer, but I'll leave it as it is. You all can change it if you feel like it. So as far as Multer is concerned, before what we were doing is we were going a directory up, so it was /uploads, but when we are actually deploying it to Docker, we'll probably have to change this to like inside this uploads inside the current directory itself. So that's all the changes which was made for the Express. Now let me close all the open editors and move to FastApi, but I don't think there's any changes which was made in here. Everything still remains the same. Nothing has changed, so let's not go over this again. I don't want to repeat myself. So I've not made any changes to FastApi. So now let's get into the more fun part of this video, which is the Docker part. So here what we are doing is, let me actually stop our running instance of our container. So I just control C it and everything is shutting down, right? So if you all want to mimic this project in your devices, what you can do is just pull it from the GitHub, and what you'll have to do is you'll have to enter this command called docker compose up ---- build, and you just press enter, and it should start building your containers, and make sure Docker and all is installed. So once that's done, it might initially, it will take some time. So the first time when you build this, it might take about 5-10 minutes depending on the speed of your application and all, but after that it's much more faster. So once you've done building it, to run your server, all you have to do is press in this command called docker compose and up, which will just start all of your servers, which is your Postgres, FastApi, the Express, and your frontend. So just hit enter and your container should start running, right? So that's how you would start your container. So now let's go over this docker compose YAML file. So here let's start off with Postgres DB. So this is just a service name, and you can literally name it whatever you feel like naming it. I've already actually made a video on Docker. Feel free to just watch it to get a better understanding on how this works. I go in deeper, and yeah, so this basically creates a Docker image for us. So we pull the latest image from Postgres, set the environment variables, and here what is happening is it maps the containers port to our local systems port. The same thing again with FastApi. This is a service name. You can name it whatever you feel like naming it. The build, the context is basically where the Docker file for this service is. So in our case, we are in our directory, FastApi, which is right here, and here we have a Docker file. So it just picks that Docker file and starts building it. Again, it maps the port of the Docker to our system. That's what this is. And probably this is the most important thing, which is volumes. So let me go over, I've made a beautiful illustration right here. So since we are okay, let me actually start by saying what volumes is. So whenever you want to persist your data outside of your container, so since we have a multi-container Docker, we have a uploads folder where we save the user's images for a short duration of time. So because we're saving it in a separate folder outside of the container, that is where we use volumes. So volumes is generally used to persist a data outside a container and to share data across different containers. So if you remember right here, we have a next app, Express FastApi. We send some images to Express. Express then saves the image to an uploads folder and sends a get request to FastApi. And what basically our AI model does is picks the images from uploads folder and sends the unique ID to Express. Express saves that data in a database, and then it gives the response to next app, and next app basically reroutes the user to the dashboard if it's successful, right? So this is the general flow of our application. So after seeing this image, I just remembered there's another change which I made in our Express application. I apologize because I didn't go over this previously. So if I go to my controller right here, we made some changes to our controller also. So before, what we were doing is once the user saves some users images is saved, we used to remove it as well, but I've taken that snippet of code out just because whenever a new user logins, it just overwrites this images. So it was not necessary. I just removed that. So that was another change which I made with the backend. I promise that's all. I didn't make any further changes. So that's what volume is. We want to share data across our Express app and our FastApi. So that is where volumes come in. We generally use restart when we want our service to always be running regardless of the exit code, and even if our service fails, we basically tell it to start again. Then we define our environment variables, which will be picked when our server runs. Then this depends on, basically tells start this service only after this service, which is our Express.js app. And again, all of this is the same, and yeah, that's it. That's basically the definition of our Docker container. multi-Docker container. So now let us dig deeper into these individual Docker files. So these Docker files, you don't have to actually remember anything. All you have to do is go to their documentation, because Docker has a very good documentation because everybody uses it, and you just have to find in the net which one best suits your use case. So even for our application, what I did was I just went over Google and just typed in like Docker for various servers. So for FastApi, this was the one which I found, and I literally copied it, ran the server. It crashed a few times. Then I realized that the problem was because of this volumes thing, right here, because we are persisting data outside a container, we needed to use volumes. So that is the reason why I used this. So yeah, so generally to get started with Docker, you don't actually need to learn it, because everything is there in the net and you can just Google it out. So FastApi Docker, that's what I typed in, and this is what came up. I just picked this, copied and pasted it right here. But it is useful to know what actually these keywords mean, at least the main ones, which are these: from basically picks the latest image, work directory, basically tells what is your working directory. Again this is pretty straightforward. Copy basically says take all the packages of requirements.txt and map it to this app folder and run this command, which basically installs all the packages for us, expose 8000, and the command that should be run to run a server. So that's basically it for Docker. I'm not very well versed in Docker, but for my use case, I think yeah, you don't need to know a lot. Probably when you're getting more advanced or deeper into CI/CD, you'll have to know a little more. But for our application, you don't need to know much. So that's about it. That's all the changes which I made. This is probably the last video of this series. We set out to build a face detection system where we capture the user's images, we send it to the backend, and the AI model generates a unique face ID, and then we process that data in the database. So I believe we've done that, and we can move on from this project. So I hope by going through all of these videos, you have a vague understanding on how I go about building stuff. I generally just get started and I realize that I've made some mistakes and I try to rectify those mistakes. As you can see, we started off with Golang, and then I realized that Golang is not a fit for this, and we changed it to Express. So, and same thing with Flask. We started out with Flask and we moved on to FastApi. So generally what happens is us engineers have all these great ideas, but we never get started, and because we never got started, those ideas never come into life. So hopefully if you have a great idea, just try building it, and hopefully it turns into something great. And if you've gone through all of the videos thus far, I want to say from the bottom of my heart, thank you. It means a lot, and hopefully by going through those videos, you got some value out of it. Thanks, and see you in the next video.